Strategy Management Series. Video number 116 Strategy Formulation. Step 7 Strategy Evaluation. Step-by-step guide to mixed strategies games. Welcome back to the Ready MBA series on strategy management. In our previous sessions, we delved into strategy evaluation, the crucial seventh step of the strategy formulation process. This stage entails scrutinizing potential strategies for their impact, benefits, costs, and resource requirements. We also discussed game theory, a technique for predicting competitors' moves in a competitive situation, and how it can be used by the planning team to refine their strategic analysis. One of the primary benefits of game theory is its ability to help decision-makers anticipate the potential outcomes of different strategies and understand the ripple effects of their choices. This is especially valuable during strategy formulation and evaluation, as it allows planners to simulate various scenarios and assess the best course of action. In our previous episode, we introduced the concept of mixed strategies, which involves randomizing between different strategies or actions to keep opponents uncertain about your next move. In this video, we will discuss a step-by-step guide to help the planning team identify games where mixed strategies should be adopted and how to operationalize it. Mixed strategies are a crucial concept in game theory because they help players navigate competitive scenarios where a clear dominant strategy does not exist, or where players want to avoid becoming predictable. In the business environment, mixed strategies can be applied in various situations. For example, companies selling similar products can use mixed strategies to set prices, thereby avoiding predictability that competitors could exploit. Additionally, incumbent firms might use mixed strategies to determine when to enter new markets or react to potential new entrants, making it unpredictable for potential entrants. Other applications include product launch timing, stock trading, R&D investment, advertising spend and channels, supply chain and inventory management, and security protocols and measures to prevent corporate espionage. Here's a step-by-step guide to help a planning team evaluate and use mixed strategies for a game scenario. Step 1. Define the game scenario. Identify the game environment, including players. Determine who the players are in the game scenario. This could include competitors, customers, suppliers, or other stakeholders. Choices and moves. List out the available strategies or moves for each player. Understand the potential interactions between players' decisions. Objectives. Define the objectives for each player. What are they trying to achieve? For example, are they maximizing profits, market share, or customer satisfaction? As an example, let's consider a situation in which two rivals, Company A and Company B, are making simultaneous decisions whether to invest in marketing or R&D with the objective of maximizing their profits. Step 2. Create a payoff matrix. Build a payoff matrix to map out the potential outcomes of different strategy combinations. A payoff matrix helps visualize the outcomes for each player based on their strategic choices. Identify possible strategies. Determine all possible strategies for each player. Assign payoffs. Estimate the payoffs for each combination of strategies, based on objectives and assumptions. Analyze the matrix. Look for dominant and dominated strategies, Nash equilibria, and mixed strategies opportunities. In our example, we would have the following payoff matrix. If both companies invest in R&D, both will have $1 million in profits each. Conversely, if they both invest in marketing, their profits will be $3 million each. However, if Company A invests in R&D and Company B invests in marketing, A's profits will be $4 million whereas B's profits will be $2 million. The opposite holds true. If Company A invests in marketing, but Company B invests in R&D, A's profits will be $2 million and B's profits will be $4 million. In this game there are no dominant strategies. The Nash equilibrium in this game is when both companies invest in marketing, leading to a suboptimal outcome with both making lower profits. The ideal outcome would be where one invests in R&D and the other in marketing, but it is unclear which strategy the competitor will choose. Step 3. Identify opportunities for mixed strategies. Mixed strategies are useful when 1. No dominant strategy exists. If there's no clear dominant strategy for a player, consider randomizing their moves. 2. Avoiding predictability. If a player's strategy becomes predictable, they can be exploited by their opponents. Mixed strategies introduce uncertainty. 3. Finding equilibrium. Sometimes, mixed strategies can help reach a Nash equilibrium where each player's strategy depends on the other's choices. In our example, there are no clear dominant strategies, and neither company wants to risk always choosing the same option, as the competitor could exploit this. Mixed strategies allow for unpredictability, reducing the competitor's ability to predict strategic moves. This flexibility is key to achieving a better outcome, as it complicates the competitor's decision-making process. Step 4. Derive probabilities for mixed strategies. Mixed strategies involve making strategic decisions with a certain probability or randomness to avoid predictability. These probabilities are derived from the analysis of payoff matrices and the conditions that lead to optimal outcomes or Nash equilibrium. When using mixed strategies, players might choose any of their strategies with some probability. If player 1 has two strategies, let's call them A1 and A2. Let's say player 1 chooses A1 with a probability P, and thus A2 with 1 minus P. Similarly, if player 2 has two strategies, B1 and B2, let's say player 2 chooses B1 with a probability Q, and thus B2 with 1 minus Q. The expected payoff is the average amount a player can expect to earn from a particular strategy, taking into account the probabilities of all possible outcomes resulting from the other player's strategies. For each player, calculate the expected payoff for each of their strategies by multiplying the payoff of each possible outcome by the probability of the other player choosing their respective strategies, and then summing these values. This gives the expected payoff for each strategy, considering the mixed strategy of the opponent. In a Nash equilibrium, players are indifferent between their strategies. This would mean that the expected payoffs for the different strategies should be the same. By doing so, we can derive the values for probabilities Q and P. Now let's use our example to show how to calculate these probabilities. Assume each player might choose any of their strategies with some probability. As we saw, Company A has two strategies, R&D and marketing. Let's say they choose R&D with a probability P and thus marketing with a probability 1 minus P, since both should add to 1, or 100%. Similarly, Company B has the same two strategies, R&D and marketing, and they will choose R&D with a probability Q, and marketing with a probability 1 minus Q. Now, we must determine what each player expects to get for each of their choices, considering the probabilities of the other player's choices. These are the expected payoffs. If Company A chooses R&D, their expected payoff will be defined by Company B's choice of either R&D or marketing. Therefore, Company A's payoff for R&D is equal to Q multiplied by 1, A's profits if B also chooses R&D, plus 1 minus Q, multiplied by 4, A's payoff if B chooses marketing. We do the same for the case of Company A going for marketing. A's marketing payoff will be equal to Q, the probability that B chooses R&D, multiplied by 2, which is A's payoff for B choosing R&D, added to 1 minus Q, times 3, A's payoff for B choosing marketing as well. Now we must do the same for Company B. Let's start by calculating B's payoff if they choose to invest in R&D. In this case, B's R&D payoff is equal to P, probability that A chooses R&D as well, times 1, B's payoff in this case, plus 1 minus P, multiplied by 4, B's payoff if A chooses marketing when they decided to invest in R&D. Last, but not least, we need to calculate B's last payoff, which is the payoff if they decide to invest in marketing. In this case, B's marketing payoff equals P, probability that A will choose R&D, times 2, B's payoff if A chooses R&D when they choose marketing, added to 1 minus P, multiplied by 3, B's payoff if A also chooses marketing. The final payoffs in this game using mixed strategies, considering the probabilities that A and B may be using, are as follows. For company A, when choosing R&D, the payoff equation is 1Q plus 4 times 1 minus Q, or 4 minus 3Q. Company A's marketing payoff equation is 2Q plus 3 times 1 minus Q, or simply 3 minus Q. Now, for B's R&D payoff equation is 1P plus 4 times 1 minus P, or 4 minus 3P. The last payoff equation, when B invests in marketing, is 2P plus 3 times 1 minus P, or just 3 minus P. Step 5. Calculate the probabilities for mixed strategies. In a mixed strategy Nash equilibrium, each player should be equally happy with any of the strategies they are mixing between. This means that the expected payoff of company A choosing R&D should be the same as choosing marketing. Therefore, the two payoff equations previously defined should be equal. By equalizing the two equations, and solving the simple linear equation, we would have that 2Q equals 1, or Q equals 0.5. We do the same equalization for company B's payoffs so that B is indifferent to pursue either one of the strategies since they both have the same payoffs. In B's case, we find that 2P equals 1, meaning that P equals 0.5. So, for both companies the probabilities that they should use to alternate their strategies should be 50%, which constitutes the Nash equilibrium of the mixed strategies game. In this equilibrium, by switching strategies at this rate, both players would have no incentives to pursue a different strategy. Step 6. Communicate and monitor. Communicate the decision to use mixed strategies to stakeholders. Monitor the outcomes to assess whether the strategic mix yields the desired results. Adjust probabilities if needed, ensuring a balanced approach. Step 7. Adapt to market changes. The planning team should be adaptable to changing market dynamics. If the competitor adjusts its strategies, the planning team should reconsider its mixed strategy probabilities to maintain competitive advantage. Benefits of using mixed strategies. Mixed strategies introduce uncertainty, making it harder for competitors to anticipate moves. They allow for greater flexibility and adaptability in strategic decision-making, promoting a balanced approach to competitive scenarios. By following this step-by-step guide, the planning team can effectively use mixed strategies to gain a strategic advantage and avoid the pitfalls of predictable moves in competitive environments. And this concludes our episode describing the step-by-step to identify when and how to use mixed strategies in simultaneous moves games. Please join us in our next episode where we will continue our discussion about game theory. Until then, keep strategizing. See you soon.